Alright guys, so the point of this video, the reason why I'm talking about this here is because I missed some things, like things I just want to explain a little bit further, and I want to do more examples before I set you guys loose on the homework assignment. I realize you guys might be confused when something's not a polynomial function, so we'll talk about that. But first, let's talk about this here. This is something I kind of missed that I wanted to talk about. I wanted to go over in that last video that I just didn't think about. So let's go ahead and think about this here. So what is the difference between just the normal integral of f of x dx and the integral from a to b of f of x dx? So let me explain this. So the difference here, first of all, this guy means just find the antiderivative. All right. So remember when we did that, we spent one day finding antiderivatives. We found we would find the equation that if we would have taken the derivative of that equation, that would have given us f of x. Okay. So, and then remember, we always put a plus c, okay? We put a plus c because there could have been some constant that we didn't know about, that when we took the derivative of it, it gave us 0. So, we've got, essentially, this just means find the antiderivative. This guy right here means find the area under the curve from some interval, all right? And we do that by finding antiderivatives, but we take it a little bit further. Remember, the last video we said, in order to find this, you take capital F of b minus capital F of a. So what I'm going to try to show you is why that's true. Okay, I gave you that formula, but let me show you why it works. So first of all, this right here comes from the fundamental theorem part 1 of calculus, this fact right here. Okay, so the integral from a to x of f of t dt, that's the same thing as capital F of x plus c. All right, so that's what we would do. We would add that c when we found the antiderivative. So remember, this is the antiderivative, and then we've got plus c. Okay, so I want to get from here, and I want to show you guys how we got capital F of b minus capital F of a. All right, so here we go. So to talk about this, let's just say, instead of going from a to x, let's say if we change this, let's say we go from a to a of f of t dt. Then what that would be, if I changed a to x, then therefore this would be capital F of a instead of x. We would plug a in for t instead of x. Okay, we still have this plus c. Now, if you guys remember properties of integrals here, if we ever have an integral from a to a, if you look back at those, this was from section 5.3. So if you look back at that, you'll notice that this property right here, if it goes from a to a and not from a to b, then really we're not going to have an area under the curve here. Because if we only go from a to a, that's essentially just finding the area of a line segment, and line segments don't have areas. So the area here is going to be 0. So 0 is going to be f of a plus c. And then if we want to solve, let's say we want to solve for c, figure out what c is. Well, that's going to be, we're going to have to subtract f of a, capital F of a, and what we're going to be left with is negative f of a is going to equal c. So guys, to kind of wrap up here, so what we just found was that c is going to be the same thing as negative f of a. So if that's true, I can go back up here and I can plug in negative f of a. So to rewrite this guy right here, I'll just rewrite it on another page. So to rewrite that, it's going to be the integral from a to x of f of t dt. And that's going to be the same thing as capital F of x minus capital F of a. Alright? So that's where this comes from. Now, that doesn't look exactly like the fundamental theorem part 2. But the only reason it doesn't is because we have x here instead of b. So if I want to write it like this, from a to b of f of t dt, then that's going to be capital F of b minus capital F of a. There we go. So that's where it comes from, guys. That is why the fundamental theorem of calculus part 2 is true. All right, so and guys, you can replace this instead of f of t dt, you can say f of x dx. That works as well. All right, so that's the reason that works. Okay, so I just want to make sure I pointed that out. I left that out on my last video. All right, so Another thing to mention before I move on. So if you have just a normal integral, you'll always have to put that plus c. Okay, if you have a normal integral, it'll have to be plus c. If you have something like this where you want to find the integral over an interval, all right, what you need to do is use that formula f of b minus f of a. You don't have to worry about c because c becomes negative f of a. All right, so you don't have to worry about putting plus c when you actually want to evaluate the area under a curve. When you just want to find a normal integral, if it just says, and by the way, when I say normal, this is an indefinite integral. This is a definite integral. All right, let me say that again. This is an indefinite integral. This is a definite integral. Okay, so if we want to find an indefinite integral, we need that plus c. If we want to find a definite integral, we don't. We use the formula capital F of b minus capital F of a. All right, so that is what I missed from the video. Now, I also want to go over a couple more examples. So here we go. Now, I printed off a formula page. You're going to be able to use this formula page on a test, okay? So this is all the antiderivative formulas of different functions, okay? Now, these formulas come from the derivative formulas, and I gave you those when you guys took the test over derivatives. I'm going to give you these for antiderivatives as well. So let's look at this. So let's first, this is one of the formulas, and I want to kind of explain why this one's true. So let me just give you an example here. So this is one of the formulas on your formula page. Look at it and we'll talk about why this is. So let me give you an example here. So this is an example where you use this formula. So what if we had the integral of, yeah, how about we just let it be x to the negative 1 dx. Now notice this is the indefinite integral, okay? So we're going to have this plus c. You guys see what that is? Right? It's an indefinite integral. Okay, well guys, x to the negative 1, you guys should understand, is just 1 over x. It's going to be dx. Now, what I want you to think about is what we've always been doing with polynomial functions or rational functions. We add 1 to the exponent, and then we subtract 1. What am I saying? Sorry. We add 1 to the exponent, and then we divide by the new exponent. Okay, so in this case, what happens? Oh, sorry. What happens? Pause for the laughter there. Okay. So what happens if we add 1 to the exponent here? Well, we'll just look at this. Don't worry about this guy right now. We'll look over here on the left side. If we add 1 to the exponent, it's going to give us x to the 0. But now, what if we divide by the new exponent? Well, the new exponent is 0. So if we divide by 0, well, that's bad, isn't it? We can't divide by 0. It's undefined. So, but there is still an integral. There is still, you can still differentiate here. And so we have to use this formula, okay? So it is actually ln of the absolute value of u, okay, plus c. So guys, in order to evaluate this, the answer here is going to be ln of the absolute value of x plus c. All right, so that kind of gives you an idea. Actually, I didn't need to erase that. Let me leave that up there. Okay, it was x to the 0 over 0. Yeah, so this is ln of the absolute value of x plus c. Now, I'm not going to show you the proof of that. It'll take too long, but that is always going to be the formula we can use. All right, so if you ever see this happen, there's the formula you need. Okay, ln of the absolute value of x plus c. All right. So that's one thing I wanted to explain there. Now let's just do an example here of something that you might need to use here. So what if we wanted to evaluate, let's do this. We'll do a trig ratio one. All right, so this is just an example of trig. So negative pi over 4 to negative pi over 6 and of 2 cosine of x dx. Alright, so what you're going to need to do is look at your formula page, and let me show you the formula page. I'm going to make sure that guy, okay, it has chapter 6 here. There's your formula page. Okay, now if you look at sine, I don't know if you, well actually not sine, cosine, the integral of cosine is sine u plus c. Okay, so let's use this. Hopefully that focuses again. All right, looks like it's focusing. So we're going to use this to solve this problem here. So notice, this is a definite integral, okay? So if this is a definite integral, what we need to do is use the formula, capital F of B minus capital F of A. But we need to find capital F. And remember, capital F is the antiderivative. So, you got the formula to talk about the antiderivative. But before we do that, guys, one of the properties of integrals is that anytime I have a coefficient, I can just write it off to the side. Let me do that first. Now, you don't have to do this, but I'm going to choose to. All right, so you can bring the coefficient out there. Now, all we got to do is find the antiderivative. Well, we've got the formula for it. The antiderivative of cosine is sine. So let me do this. It's going to be 2 times parentheses sine of x. And then we want to evaluate sine from negative pi over 4 to negative pi over 6. All right, so let's go. Let's get started here. So what we need to do here is, again, we're taking 2 times f of b minus f of a. That was the second part of the fundamental theorem of calculus. Okay? So what is b in this case? Hopefully everybody knows what b is. B is going to be negative pi over 6 minus f of a, which is negative pi over 4. There we go. So let's keep it going. Pause if you need to. So let's figure out what f of negative pi over 6 is. In order to do that, we got to plug it back in to the function. So it's going to be sine of negative pi over 6 minus sine of negative pi over 4. Okay, so guys, we're going to have to use the unit circle here to figure this one out. Let me go to it real quick. I'll try to bring this up. I'll bring up a new page. Open. Go to advanced math, and we talk about unit circle. Here's one. So think about where negative pi over 6 is going to be. It's going to be this point right here. That's negative pi over 6. We're going pi over 6 clockwise instead of counterclockwise. So that's positive pi over 6. We have to go that same angle that way. So it's negative pi over 6. And negative pi over 4 will be right here. So guys, remember, sine deals with x or y values. That's a question. Does sine deal with x or y values? The answer, hopefully everybody says, y values. So what is the y value of that point? Is that the smallest y value, the middle one, or the biggest? It's actually going to be the smallest absolute value. And so therefore, negative 1/2 is going to be the sine of negative pi over 6. Okay? So this is negative 1/2. And then we've got minus, negative pi over 4. We've got to figure out the sine of that. Well, that's the middle value, the middle absolute value. So therefore, that's going to be negative square root of 2 over 2. The y value here. So negative square root of 2 over 2. Notice I'm just keeping this negative because the formula tells me to do that. 2. Alright, so it's really like adding the opposite. But guys, when I multiply these both by 2, the 2's go away. They cancel on bottom, top, and bottom. So those cancel. So we're left with negative 1 plus the square root of 2. Whatever that is as a decimal, that's going to be your answer. If you wanted to leave it like that, you can as well. So I'm going to actually circle that. Negative 1 plus the square root of 2. Alright, so that's just an example of how you can use these formulas. Guys, you've got the formulas, use them to do these homework assignments. So just want to go over a couple examples there, and hopefully that made sense. Okay, I'm going to stop this video right here and try your homework, and if you have questions, you can comment on Google Classroom. You can ask Mr. Frazier if this is the right day. You can ask a classmate. So work together. All right. Thanks.